in an array. Inside of the array, it is non-negative integers. Yeah, as we can see from the array, it is more than or equal to 0, less than array.length. And we have some calculations about the jump. So from the position I, so I is the index position. For example, the start equal to 5, so 0, 1, 2, 3, 5. So this is the index position. But you can jump I plus array I. So this means from this position, so it can jump to 5 plus, so this is 0, 1, 2, 3, 4, 5. 5 plus 1 or 5 minus 1. It can jump to this position with number 2 or number 3. So, for example, from index 5 to index 4, and from index 4 can jump to index 1, and index 1 can jump to the right 2 positions, can jump to index 3 with a value 0. If we find a value of 0, so we're gonna stop and return true. If we cannot find, we're gonna return false. As you can see from it, it is a typical BFS problem. So the starting point is this start. So the ending point is the value of 0. We also need a weighted set to check which index is weighted. Now let me prepare a queue. Inside it's gonna be the start, and I also need a set. Let me use a weighted set. So inside it's gonna be also the start because it is the index. Now I'm going to check the queue. So the node should be equal to q.pop left. So if this value of the node equal to 0, we're gonna return true. Otherwise, we're gonna check the neighbors. So the neighbors is just inside, with this one. I plus array I minus array I. So if I gonna use this I variable, so here I'm gonna pop out this I. So I'm gonna use I is the node. So I plus array I and I minus I. I'm going to check the neighbor. So the neighbor must be inside the boundary. It must be more than or equal to 0, less than the length of the array, because this is according to the question. So this is array I. This is array I. This is the value of array I. But for the node, this is the index. So the neighbor is index. It must be more than or equal to 0, less than the length of the array, because we are going to check the index. As you can see, the start, it's for this one. This is the index. So if it meets the conditions and the neighbor not in weighted set, so we can put it inside the weighted set with this neighbor. And the queue should append this neighbor. Finally, we're gonna return false if we cannot return a true. This is the entire code. Now let me run it. As you can see, it works. Now let me submit it. As you can see, it passed for all the testing cases, and the time complexity is ON. N is 5 times 10 to the power of 4. Because for each of the positions, for example this one, it can only go to 2 positions. We just need to loop through all the node. So the time complexity is ON, and it is a sparse graph. Thank you for watching. See you next time.